So let's take a look at number 5. And as you can see, there's several things that we need to answer. A, answer the vertex. B, the equation of the axis of symmetry. C, either an XY table or the pattern that you're using. D, the y-intercept. E, max or min. F, domain. G, range. H, state the x-intercept. So you have 1, 2, 3, 4, 5, 6, 7, 8 points. This is probably worth 2 or 3 points, the actual graph itself. So it's going to be like a total of 10 points each one. So let's do number 5 together. And we always start with the vertex. I always say write the word vertex, write the coordinate. It's already there for you. Let's write down the formula. X equals negative b over 2 times a. Let's rewrite it with parentheses. X equals negative parenthesis over 2 times parenthesis. Let's identify the a value of 1, the b value of negative 6, and the c value of 4. So we could actually plug in the b value of negative 6 right in there and the a value of 1 right down there. Now we do have a minus minus, a negative times a negative is a positive. So we really do have 6 over 2, which means that the x value is really 3. So I have the x value of the vertex. I need the y value. So what I'm going to do is rewrite this entire equation, but instead of instead of x's, I'm going to put parentheses to plug in that 3 right in there. As you could see, I rewrote it with parentheses. Now I'm going to write the 3 right in there on both of them. And when we work this out, we have 3 squared because we do exponents first. 3 squared is 9. And then after exponents is multiplication. So we do have a minus 6 times 3. So negative 6 times 3, that's negative 18. Bring down the plus 4. And then from left to right, we're going to go 9, take away 18. That is negative 9. And negative 9 plus 4, that is negative 5. Ladies and gentlemen, this work right here shows the work that we need to be able to get that y value of the vertex, which is negative 5. Now, without the work on the quiz or test, you're not going to be able to get this credit. So you need to show me the formula. You need to show me that you plugged in the b and the a to find the x. You need to show me that you plugged in the x value to find the y value in order to get credit for the vertex. So I still need to think of how much each part of the answers are worth. For sure, the graphing's worth the most. The vertex should be worth more than the rest. Anyways, let's graph that vertex. So the vertex is 3, negative 5. 3 on the x, 1, 2, 3, negative 1, 2, 3, 4, 5. So 3, negative 5. Let's all graph that. And whenever you graph that vertex, immediately you should draw the axis of symmetry right through that vertex. Remember, the axis of symmetry is the vertical line that crosses right through it. And if you look at part B, it's asking for the axis of symmetry equation. So we already know this is the axis of symmetry, but what is the equation that actually produces that vertical line? That's the equation x equals 3. You have to put x equals, right? Without x equals, it's not a line. That's just the number 3. You have to put x equals 3. That produces the vertical line crossing through the x value of 3 right through that vertex. So you get another point for that. And then we move on to either making an XY table or using a pattern. If you want to make an XY table, that's fine. Plug in some numbers, pull out some answers, but you have to do a lot of math. So what I like to do, especially when my a value is 1 or negative 1, I like to do the pattern 1, 1, 2, 4, 3, 9. These are not coordinates. These are a pattern from the vertex. So again, remember, when we use this pattern, it's from the vertex. Okay, these are not coordinates, it's a pattern from the vertex. So from the vertex, we need to first, again, recognize that this opens up or down. What do you guys say? Opens up because the a value is positive. So now I know that I'm going to go 1 over 1 up. So 1 over 1 up. If it were a negative a, I would go 1 over 1 down. But because it's a positive a, I'm going to go 1 over 1 up. So 1 over 1 up, put a dot right there. And then I go back to the vertex, and I'm going to go 2 over 4 up. So 1, 2, 1, 2, 3, 4. Let's put a dot right there. And then we go to the last one, 3, 9. Again, back to the vertex. Go 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 right there. And then, of course, because we have that axis of symmetry, we're able to map it over to the other side. So just count how many units away from the axis of symmetry you are. So right here, 1 unit. So go 1 unit, put a dot right there. And then you go how many units on the next one? 2 units. So go 2 units this way, put a dot right there. And the last one, it's 3 units away, so put it 3 units away from the axis of symmetry. And we graph our parabola right through those points. And then we continue on. I mean, the most points on this question comes from this perfect graph that we've done. But let's continue on and answer the rest. So letter D, it says the y-intercept. Okay, what does y-intercept mean? It means where your graph crosses the y-axis. So here's my graph. Where does it cross? Here's the y-axis. Where does it cross? Right there. So you could give me the coordinate. Right here I wrote coordinates. On the other ones I didn't. So you could give me the coordinate of the location of where my parabola crosses the y-axis. And that would be 0 on the x, 1, 2, 3, 4 on the y. So you could put 0, 4. Or you could just say y-intercept is 4. Okay, either one is fine. So the y-intercept's 4, or you could give me the location 0, 4. Now, do we have a max value or a min value? That's a min value, so circle it, you get the point right there. Okay. Now, just to reiterate, what is the minimum value? You could either give me the location of the vertex. So if they asked you what is the min value, you could say that the min value is at 3, -5. Or you could also say that the min value is -5. Just the y. Because after all, maxes and mins are really talking about the y value, right? So you could give me the actual location, the vertex, or you could give me the minimum y value, which is -5. And we need to understand the minimum y value being -5 when we come to talk about range. The domain should be a free point for everybody. So once again, the domain of any parabola is going to be x equals all real numbers. The range of the parabola is it's either above or below a certain value. In this case, we know that the minimum value is -5. What does that mean? That means that the parabola, the lowest it gets on the y, is -5. So it's at -5 and it's above -5. So what do we say the range is? Y is greater than or equal to -5. Once again, the parabola, what's the minimum value on the parabola? It goes down, goes down, goes down. It reaches the lowest point. This lowest point is the y value of -5, and then it goes back up. So this entire graph is at this point or above. It's at this point or above. So what is this level? That's the -5, and it's above -5. So how do we say that in terms of an inequality? Y is above -5 and at -5. That'd be y is greater than or equal to -5. And the last question I'll be asking you for this one single question is to state the x-intercepts. Now this is very important right here. It says approximate if necessary. Okay, now sometimes you're going to get locations that are nice. Like sometimes it'll actually cross at 1 and at like 8 or something like that. But right here, as you can see, the dots are not nice right there. Those are going to be fractions or decimals. So I say approximate, all right? So let's approximate. Let's zoom in. And what would you guess this x value is? This is 1, so what's this right here? 0.9. All right, or 0.8, whatever you want, okay? An approximation is all I'm asking for. So H, state the x-intercept. You're going to say x-int is 0.9, somebody said. And then how about the other one? Let's check it out. The other one, here's 0, here's 1, 2, 3, 4, 5, 6. So where's this at? If this is 5, where's this at? 5.1. That's good. Okay. So x-intercepts are at 0.9 and 5.1. And you know what? Something that's incorrect. I shouldn't have put equals. What I should have done is a little squiggly equal sign. That means approximately, okay? So we actually have two answers. Now, sometimes these answers will be nice. So right here, they're not nice. They ended up crossing, and we're given an approximation here. Next week, we're going to learn and use the quadratic formula. Those will give us exact answers. This is just an approximation. Like right here, the answer is 0.9, but maybe next week we find out it's not 0.9, it's 0.8257 or something like that. Anyway, this is good enough, and this is all you need to do to get full credit on one question on tomorrow's quiz. Once again, each one of these is worth 10 points because there's so many things to answer. Okay, so let's jump to number 6. Now, some of us are confused with number 6 because the A value is 2. That means that you can't use the pattern 112439 as it is, but you could modify that pattern by multiplying the outputs by 2. Anyway, let's start the way we always would. Let's find the vertex using the vertex formula. And let's know how to use that formula with parentheses. And let's identify the A value of 2, the B value of -8, and the C value of 4. And let's plug in the B value of -8 right into those parentheses and the A value of 2 right into those. So we end up with +8, because a minus minus becomes plus plus, +8 over 4, which means that our X value is 2. So it's the same deal as before. It's pretty easy, right, Ismail? And let's plug in the value of 2 into the original equation. And I always recommend replace the variables with parentheses, just like we did on the formula when you plug in any values. By the way, some students are asked, what's the difference between y and, like on the previous one, f of x? It's the same exact thing, all right? It's the same thing, so don't worry. F of x is the same thing as y. Anyways, let's plug in that vertex x value of 2 right in there. Let's work it out using PEMDAS. So parentheses, there's nothing to do inside of the parentheses. We go to exponents. 2 squared is 4. And then I need to multiply it by 2. And then I also need to multiply 8 times 2 and then bring down the plus 4. So I'm doing one step at a time. Let me do the multiplication next. 2 times 4 is 8. Minus 8 times 2 is 16. Bring down the plus 4. 8 minus 16 is -8. -8 plus 4 is -4. So -4 is a vertex y value. Now that we know that vertex, I'm starting to think on count vertex as 2 points maybe. Who knows? We'll see. Let's graph that vertex of 2, -4. 2 on the x, -1, 2, 3, 4 on the y. Put a dot there. After that, draw your axis of symmetry right through it. And then we also have to write the equation of that axis of symmetry, which is x equals the x value of your vertex, which is 2. You have to put x equals 2. Can't just put 2. Moving on to step C, part C, XY table or pattern. Okay, so let's say you wanted to use the XY table. Maybe I'll do both on this video, XY table, or you could use the pattern 1, 1, 2, 4, 3, 9, but you have to modify the pattern if you're going to use the pattern, okay? So if you're going to use the pattern, the A value is not 1, so you can't use that pattern. The A value is 2, which means that you got to take these guys and multiply them by 2. So you're going to have to change the 1 into a 2. 1 times 2 is 2. 4 times 2 is 8, and 9 times 2 is 18. So your new pattern, your new modified pattern for this equation that has an A value of 2 is 1, 2, 2, 8, 3, 18. So if I wanted to use this modified pattern of 1, 2, you go 1 to the right and then 2 up and put a dot right there. And then you go back to the vertex and you're going to go 2, 8. So 2 to the right, 1, 2, 3, 4, 5, 6, 7, 8 right there. And 318 is going to be off the graph. I'm not going to do that. I am going to map them over to the other side of the axis of symmetry. And then I'm going to simply draw my parabola. Try to make it a little curved right here as you get to the vertex. All right, guys? It's definitely not a V. Some people just draw like a V. That's incorrect. Anyhow, that's our parabola. Let's say you wanted to use an XY table. which is totally fine. Okay, so I already graphed it, but I'm going to pretend that I didn't use the modified pattern. If I wanted to use an XY table, the easiest input to plug in, if it's available, that's like if you haven't plugged it in already on the Vertex, the easiest value to plug in is what? The easiest value to plug in is what? 0. So it is available. Let's use 0. When you do plug in 0, you get the C value as your output. So the input of 0 gives us the output of 4. And look at, if you actually graphed, here's 0, 0. If you graph 0, 4, you'd go 1, 2, 3, 4. There's your dot 0, 4. You map it over to the other side, you get that dot over there. And you probably want to plug in one more number, probably like the number 1. And if you did plug in the number 1 up here, this is the reason why I like the pattern instead of plugging in. Because if you did plug in a 1 into the equation, you'd have to do a lot of math. 1 squared is 1. 2 times 1 is 2. 8 times 1 is 8. 2 minus 8 is minus 6. Minus 6 plus 4 is negative 2. So when I plug in a 1, I get out a negative 2. Okay? And that's the actual coordinate. If I did go to the coordinate 1 and negative 1, 2, I'd get that other blue dot, and I'd reflect both of them over to the other side, and I have that same parabola. So it's totally up to you if you want to use the pattern, but you have to modify it because the A value is 2, or an XY table. So let's look at the y-intercept value, guys. What is the y-intercept on this parabola?
0, 4.
You could give me the coordinate 0, 4, or you could just say y-int equals 4, right? Because after all, this parabola crosses the y-axis right here at that location, 0, 4. How about, is it a max or a min value?
Minimum.
It's a minimum value, absolutely. Now, I'm not sure if I'm even going to ask this, but if I did ask you what is the minimum value, what would you say? So up here we're at 4, right here we're at 0, negative 1, negative 2, negative 3, negative 4, and then it goes back up, right? So what's the minimum value?
Negative 4.
Negative 4. So the minimum value is y equals negative 4, or you could actually give me the location of that min value, which is the same thing as the vertex to negative 4. Either way is fine. This is a good answer. I like that. I like this one better. Or you could just give me the vertex itself as a min value. Now let's go for domain and range. The domain is what?
X equals all real numbers.
X equals all real numbers. Once again, guys, don't forget the X equals. So if you put all real numbers, I have to mark it half credit. So put X equals all real numbers. Now the range, what's the range? That one's easy. Y is greater than or equal to negative 4. Okay, now remember your y values. See, here's a y value of negative 7. Here's a y value of negative 5. Here's a y value of negative 4. And it does have the y value of negative 4. This whole parabola is above the y value of negative 4. So it touches negative 4 and it's above. So we say y is greater than or equal to negative 4. Okay? So I'm going to stop this video right here. We still have 2 more on this page. And if you need help on the other ones from the other side of the worksheet, please watch the previous video. Sorry, I totally forgot about H. So let's go to H. State the X-intercepts. Approximate if necessary. So let's take a look at the X-intercepts. So here's my X-axis. Where does it cross? It crosses right here and right there. So we are going to approximate. Here's 0, 0. Here's 1. So what do you say this is right here?
0, 0.2,
0.2, right? 0.5 would be perfectly in the middle. It looks like it's a little bit this way. So 0.2, right? And how about this one over here? Is 1, 2, 3, 4. So what is this? 3.5 is a good approximation. So 0.2 and 3.5 for the X-intercepts. Let me write that down. X-int, 0.2 and 3.5 approximation.